All right, so 7.5 notes, systems of inequalities in two variables. This is going to be great.
This is going to be super fun. Actually, we're going to start all this off with a little quick reminder of
some things you learned back in Algebra
way
1,
back
Algebra
in
2,
yeah.
just simple inequality graphing like x is greater than -1. Remember, that's a dashed line.
Why is it a dashed line?
Because it's not equal to.
It's not equal to 1.
And x equals -1, that's what we start off graphing. That's a vertical line at -1.
Right, and it's dotted.
And it's dotted or dashed, depending on how your perspective on
because you can't actually include -1. Like -1 is not greater than -1.
Right.
It's equal to.
Right, and then we shade where the numbers are bigger than -1, which is to the right, whenever we have a vertical line. Excuse me.
Right, it's just like the number line from kindergarten. Bigger numbers on the right, smaller numbers on the left.
Absolutely. Now, y is less than or equal to 5. That's a horizontal line at 5, and it's solid because it's equal to. Then when we shade, it's less than.
It's like a temperature gauge. So the greater numbers are up and the lesser numbers are down. So if this says y is less than or equal to +5, then we're actually going to shade on the underside of that
underneath,
guy.
Right
there you go. There it is right there. Now, the third example is actually a line, and it requires a little bit of work to get to the shading.
Right, because ideally we'd have this solved for y, so we'd subtract 3x over, and then have -4y is greater than 12 minus 3x. And then when we divide by -4, remember we flip that inequality around.
And you can't forget that. That's one, error number uno when you deal with inequalities is when you divide by that or multiply by that -1, you got to change the inequality.
Right, so now it's just slope-intercept form. So graph at -3, go up 3, right 4.
Dotted line again because it's equal. It's not an equal to situation.
Right, and then for the shading, anytime it's y and then it says either less than or greater than, you can tell because less than will be below the line, greater than will be above the line. So I like to, when I'm not sure which side is above and below, because some of them are tricky, if you just pick a point on the line and draw an arrow down, that's the side that's below.
Right. The other thing that you can do is you can always check any point that you want, and it's unless the line goes through the origin, always pick 0, 0. You can put 0 in for x, you can put 0 in for y.
And then see if it's a true statement.
And see if it's a true
statement. Just like this is happening right now.
Yeah, so there you go. Is 0 less than -3?
No,
I don't think so.
No,
I don't
it's
think
not,
so.
which
True
is why
story.
we didn't shade on that side.
Right. So don't make it that way.
Yeah.
Okay, it might happen where this is what you get.
Yeah. Now we're getting more pre-calculus-y down here with example 1 because our graphs are trickier. So this is a parabola that opens up and is shifted up 1. You can graph it on your calculator, but if you remember, it's really not that hard to just graph it freehand.
Right. No, and this is where your whole translation of graphs comes into play. We know what x squared looks like. We know what +1 does.
Absolutely.
So use that knowledge to help you graph this guy. And we're not looking for a 100% exact right-on graph through the point 1, 1 and 1, 2 and all. We're not looking for that. But we do need a pretty good approximation.
Right. So it's dashed because it's not equal to.
Right.
And then in general, with parabolas, it can be tricky. If it's less than and we have a parabola opening up, it should be shaded on the outside.
Right.
But it's always good on graphs you're not sure about to plug in that point and make sure. So if we plug in 0, 0, we should get that that's a true statement. 0 is less than 1.
Right. Right.
Which means that we're going to shade all around the outside of the parabola.
Because that's a true statement, like 0 is less than 1.
Yeah.
So don't make something that's true false or something that's false true. If you do the math correct, shade how it's indicated.
Exactly. This kind of equation needs to start to be familiar to you. This is a circle centered at the origin with a radius of 5. And I know that because it's x squared plus y squared and then r squared is on the right side.
Right, which we've seen this equation several times already this year. We just haven't necessarily talked about it in this way.
Right, and it's definitely going to come up a lot in this section. So it'd be easier, instead of solving it for y, plugging it into your calculator, it'd be easier if you just get on board and graph it by hand.
Right, just remember, and you should remember this from your geometry days too. You've seen this before, although it might have been a little while.
Right, so here's a nice dashed circle.
That's a really good circle.
Yeah. And
look at that. Look at that dashed circle.
Thank you. I'm trying really hard. Okay.
Man, I'm taking a picture.
Okay, less than on this
is
one
great.
is going to be inside the circle. Less than is inside the circle, greater than is outside the circle. So you can check a point again.
There we go.
0 squared plus 0 squared is less than 25. That's true. So that is inside of our circle.
And so there you go. It really is just that simple. Don't make this harder than it needs to be. We're going to ratchet up the complexity here in a few minutes. But these guys...
Ratchet up?
We're going to... Like the old-fashioned ratchet, not the
like
new.
Torque it up?
Yeah, torque it up. We're going to torque it up.
Not torque.
Not, yes. Nobody wants to see us twerking.
No, it's not going to happen.
Bad deal.